Right, part A, let's write down the equation first. Log 6x base 3 equals to 2 log 2 base 3 minus log x plus 3 base 3 plus log 8 base 3 2. Notice that there are 4 terms here. So the first 3 are all in base 3. So we can change the final term here into a base 3 as well. So log 8 base 2, right, is actually log 2 cube base 2. So you can bring this down. So this will be log 2 base 2, which is just 3. You can change it into log 3. Sorry, base 3. So 3 power 3 gives us 27. So this will be correct. So we can change this term into a log 27 base 3. So it will also give us an answer of 3. So log 6x base 3. Now this following logarithm rule, so the 2 we can bring this up to the power of the 2. So log base 3 2 square minus log x plus 3 base 3 and log 27 base 3. Now all terms over here on the right side are all in base 3. So we can just follow logarithm rule again. So any logarithmic term represents an index, so all the power. So this is subtracted. So difference means that it must be a quotient form. So base 3 of the 2 square over minus, so over x plus 3. Now if you follow with the plus, so if the negative, so minus, the difference means that it's in the quotient division form. So positive would mean that you multiply to it. So it's a multiplication. So you just multiply 27 to it. You can put a 27 there. So everything simplified to one logarithmic term over here. Now, since they are both the same operator, log base 3, so we can remove this 2 and simply just write the number itself. So 6x equals to this. So we can evaluate this out also. 2 squared is 4. 4 times 27, 108 over x plus 3. So solving would just means that you just bring this over and solve a quadratic equation, and you can get the answers for x. So bringing this over, so 6x times x plus 3, then equals to 108. So the equation quickly simplifies to this. So 18 based on factor 6, 3 minus 3 plus 6. That gives us 2 answers. 3 or minus 6. Now notice that minus 6, if we were to put into this term here in front of the original equation, right, this will give us a number in the bracket will be minus 6 plus 3, because x is 6. Sorry, x is minus 6, so minus 6 plus 3 is minus 3. Okay, you can log an operator on a negative number. Okay, that would be an undefined answer. Similarly, you can also check on this. So 6 times minus 6 would be minus 36, which is not possible as well. So we'll reject this, or just put not applicable, and because of the negative. Undefined. So x can only be 3. Part B. Now similarly we can follow part A's rule is just to combine them into a single logarithmic term, or we have to observe certain pattern in equations. So if a suitable substitution is possible, we can also choose to substitute. So I'll keep this as 2 log x base 4 first, because I want to change the log base x second term into a log base 4 term. So change of base rule applies over here. So the number is for the numerator, so log 16. Now the base we will put as 4. So the base here, x below, so we can choose any base we like. So in this case we will use base 4. Now this term here, ln e square, ln is actually the anti-function for exponent. So we can bring down the power first, 2 ln e. Right, and this will cancel out each other. So it will give us a value of just 1. Because base e power 2 brings down, this will be 1. We have plus 1 at the back. Log 16 base 4, so it's asking the index of 4 base to give us a number of 16. So 4 square, so the top numerator will be just a 2. This cancel out, so it will be 2 times 1. So just 2 plus 1. Now we notice that both of the first 2 terms here, both terms on the left side has this log x base 4 term. So let's use a substitution. So simple substitution, let y equals to log x base 4. And you can substitute this away as 2y minus 2 over y equals to 2 plus 1, 3. So multiplying everywhere by y, bringing this over, so we get this equation. Solving y doesn't mean you solve x yet, because the original equations asks us to solve x. So after we solve y, we have to use the y values to solve x. So y will be minus half or 2. So rewriting it, it will be just log x base 4 as half, or log x base 4 as 2. Now, since the logarithmic term represents an index, so you do not need to reject this negative, because it is possible to have a negative index. So we can solve the x. So 4 base power minus half, or 4 base power 2. Okay, you also use indices to solve this. So 2 square minus half, or 16. So this will give us half, or 16. Now part C, we are solving this equation here. So notice that there's no unknown here. We can solve this first. Okay, so this means that asking you that the power of the base 729, that will give us 3. Okay, notice that this is also, so let's say this is x, so this is also 3 to the power 6, 3, so power 1, so we can easily solve x as 1/6. So this term here would be 1/6. So by removing this logarithm, we can find out this term here. So this term, okay, is changing logarithmic form back to the exponent form. So base is 64, the index is 1/6, so base 64 power 1/6, that gives us 2. Right, because 64 can also be expressed as 2 to the power 6, so times 1/6. This in this law will tell us this is power 1. So this logarithmic term would be 2. So same thing, we change it again. So bringing back this form, this number equals to, bring back to exponent form, base x, index 2. Base x, index 2, so base square, index 2. Again, we are solving quadratic, so we just simplify. Equals 0 into this equation, and then find the factors. So 18 and 3 minus 18 plus 3. Now we have to be worried about the negative term. So usually we'll just substitute the negative term, right? Since positive can be applied here, can also be applied here, so this term will make it positive. So negative term, so negative 3 base. Negative 3 base is fine. So negative 3 times 15 plus 54, and this will still be a positive number, so it's still satisfied for both. So both answers will still be accepted.